So this video is going to be about solving the sides in a right triangle. And they're going to give us a number of problems where they're going to give us one angle and one side, and they want us to find the last side. Now we can actually do this using trigonometry. So you might be tempted to try this, for example, with Pythagorean theorem. And Pythagorean theorem is really useful when you have two sides of a right triangle. But if we only have one side, it's not going to be as helpful. So we're going to rely on these trigonometric functions, sine, cosine, and tangent. So if you guys look on the website this week, sine, cosine, and tangent, these are not very long, and they do a really nice job of explaining these three things. I encourage you to have a look at them. Those are the functions we're going to be using. There's an article by Khan Academy which has this example and more. And there is also a video where they're doing something similar to what I'm doing right now. So this is the exercise you guys are going to have to do in the end. And it's a little bit tricky. If you have any questions, feel free to email me. Or on Friday at 1 p.m., I'm planning a time for us to have a video chat if you want to join. So this is just a Zoom video chat, which you guys, I'm assuming, have used in your other classes by now. It's optional, not required, but if you do want to attend, just show up and we can talk about specific questions or just go over more examples. Finally, this is the previous topic down here. One thing I do want to point out for these problems is something about your calculators. So all calculators have two different modes when using sine, cosine, and tangent. So I can say sine of 90. And if I click sine of 90, it's going to tell me this value is 0.893999. And what that means is I am dealing with sine of 90, but not an unspecific thing. We are talking about 90 radians. And radians is a way to measure degrees. So we're used to using degrees, and that's what we're going to be using in this exercise. So just make sure your calculator is set to degrees. One way you can check is if you press sine of 90, if you're in degrees, that should give you exactly 1. If you're not in degrees, it gives you 0.8 something. So that's a good way to check. If you're really unsure about how to deal with your calculator, I encourage you, use the calculator that's available on Khan Academy. They have a really clear way of showing if you're in radians or degrees. So if there's any confusion, just use the Khan calculator. But just be aware if you're getting weird answers on your calculator, you're probably in the wrong mode. You're probably in radians when we really want to be in degrees. By the way, radians isn't any like super strange magical thing. It's just a different unit. Just like we have feet and meters, well, we have radians and degrees, and they're useful for different situations. But we'll be using degrees because those are the most commonly used for these problems. So with that taken care of, let's actually look at an example. So these examples kind of have two phases. The first one, you're figuring out, well, which trig function am I actually going to use? And the second phase is you're saying, I'm going to use that trigonometric function to use some algebra to solve for the side I'm looking for. So if we kind of consider this, great. We have a triangle, and they're giving us this angle B. They're giving us this side length here, which is 7. And by the way, think for a second, is this a hypotenuse, an opposite, or an adjacent side to our angle? And if you think about this for a second, it's actually going to be hypotenuse. If you were thinking adjacent, that's reasonable because it's next to B, but keep in mind, because it's the longest, it's going to be the hypotenuse. If it was shorter, it would be adjacent, but it's not. It's longer than this other side, obviously, so we're going to say that's the hypotenuse. And then this missing side over here, the only information we need to know is which side length is it. Well, this is going to be the opposite side because it's opposite of the angle that we have B. So I encourage you guys start these out by figuring out what's my angle and then what are these sides compared to that angle. This is the hypotenuse side of angle B. This is the opposite side of angle B. And finally, we need to know what do they want us to actually find. They want us to find this AC side. So we need to figure out a way to solve for this. All right. So first step, determine which trig function you're going to use based on the sides you were given. Well, if you guys remember, we have SOH, CA, TOA. And basically, if you're given opposite and hypotenuse, you're going to be using sine, right? If you have adjacent and hypotenuse, you're going to be using cosine. And if you have opposite and adjacent, you're going to be using tangent. So keep in mind which ones we have. In this case, we have opposite and hypotenuse. So you may have guessed we are going to be using sine for this one. We can't use cosine because we don't have an adjacent. And we can't use tangent right now because we don't have the adjacent. So we are going to be dealing with sine in this case because we have opposite and hypotenuse. So we're going to be using sine. Okay. And our next step is we're going to use the trig function you get from step 1 to solve for the problem with algebra. Well, here's what I know. I know that sine is opposite over hypotenuse. So sine of, let me undo that for a second to give me some more space. Sine of some angle equals opposite over hypotenuse. And we'll just call this our angle. So we'll call this theta. All right, so we're going to replace this equation with the actual values we have. So in this case, sine of theta, well, my theta in this case is 40 degrees. So that's the angle I know. So sine of 40 degrees equals opposite. So our opposite in this case is my question mark. So that's side AC over my hypotenuse. And my hypotenuse we're going to call 7. Okay, so my goal is I want to solve for my question mark, and we can treat that question mark as a variable. So if I want to solve for this question mark, I have two values I know. I can find the sine of 40 degrees, right? That will be a value in my calculator. So let's do that right now. Let's find the sine of 40 degrees, and that's going to be 0.64279. And let's just check that we're in the right form. So if I do this here, if I do degrees, make sure you're in degrees, not radians, degrees. We're going to do sine of 40 and 0.6427. Okay, so this is in degrees, which is good. And this value right here, sine of 40, is just this thing right here. So we could say, for example, 0.6427 equals question mark over 7. I'm not going to write it that way just yet because I don't want to have to deal with rounding and long decimals yet. So first I want to figure out how do I isolate my question mark. I have my question mark divided by 7 is this. Well, algebra says that we're going to multiply this by 7. If I multiply by 7 over 1 is another way of thinking about that. These 7s cancel out, and I'm going to multiply this side by 7. And so I find that my question mark side is going to be 7 multiplied by the sine of 40 degrees. And this is something I can do in my calculator. So I find that the sine of 40 degrees is 0.64279, and we're going to multiply this by 7. And this is going to give us 4.499 repeating, and it says round to the nearest hundredth. Well, this is the hundredths place right here, this second 9 here. And so if I'm thinking about this carefully, if I want to round to this place, I have to look at this place. This is a 9 too. So this 9 is actually going to round this 9 up. Well, what does 9 become? It becomes 10. 10 is a little bit of an issue because it doesn't fit in the place value, so this becomes a 0, and my 1 carries to the next position, and I end up with 4.50 will be my answer when it's rounded. So we do have to be a little bit careful with this rounding. We're rounding to the nearest hundred, which is 4.50. Okay, that was the first example, which is always the most confusing to look at. So let's look at another one, and we'll probably start feeling a little bit better about all of this stuff. It was a little bit fast, but we've got a couple more examples. Remember, at any point in the video, you can take a pause, try the exercise, or just walk away. That's kind of one of the beauties of doing math from home. Downside is, of course, you can't ask me questions, which can be tough. But speaking of which, you can email me or 1 o'clock video chat if you have questions. Okay, so let's look at another example. So our answer for this one would have been 4.50. Should be Control X. Okay, I was pressing the wrong buttons. All right, let us look at this problem here. So first thing I'm going to do is I'm going to get rid of my calculator stuff from before. And I need to figure out, well, which trig function am I going to be using? And so remember, I have SOHCAHTOA. And you guys will definitely memorize this, SOHCAHTOA. So I would just take a minute and try to memorize. It'll make things easier as time goes on. SOHCAHTOA. It sounds like a name. It's got a nice flow to it. All right, SOHCAHTOA. Round your answer to the nearest hundred, blah, blah, blah. Okay, so I have this angle B here. So I have my angle here. This 5 is going to be opposite B. And this question mark is going to be my hypotenuse. So I'm given an opposite and hypotenuse. So again, I'll be dealing with sine. So I'm going to say my formula for sine is the sine of my angle is equal to the opposite over the hypotenuse. If I fill this equation out, I end up with the sine of 65 degrees equals my opposite, which is 5, over the value I want to find, my hypotenuse. So in order to find this, I need to get rid of this 5. Now, getting rid of denominators is pretty easy, but getting rid of numerators is kind of tricky because you still have this like 1 over type of situation. There's a couple different tricks you can do to do this, but what I like to think of is I think I'm going to multiply both sides to get rid of this fraction by question mark. So I'm going to multiply by question mark, and I'm going to multiply by question mark. By the way, it's weird that I'm using question mark. Normally I'd use a variable like x or something, but just know that's what an x stands for. It's kind of a missing variable most of the time. So when I multiply by my question marks, those cancel out, and I'm left with 5 equals question mark times sine of 65. But I want to isolate my question mark. So in order to isolate that, I need to divide both sides by sine of 65. And these cancel out, and this does not cancel. This is just kind of left there. So we're left with our missing side is going to be 5 divided by the sine of 65 degrees. And so just to reiterate what I was doing, first step, I was just determining which function am I using. And I found I have an opposite and a hypotenuse, so I'll be dealing with sine. Second step, I kind of list out my equation. Sine of theta is opposite over hypotenuse. I put in my values, and then I have to figure out a way to solve for this. So just remember, when you're trying to solve for a denominator, one good trick is you can multiply both sides by that denominator, and then you can divide whatever's left over there. Another way of thinking about it, though, is I have had students in the past think of it as just, they think about this going up and then this coming down. So they think of it as kind of like a trade. Like if this comes up, this must go down to make the equation stay the same. And that's a totally fine way to think about it as well. So just keep in mind, if you get a tricky one where it's asking about the denominator, maybe come back to this example and that might serve you. Okay, let's delete this and try yet another one. All right, so we have our triangle here, and they give us angle A over here. They're giving us this side, which is our hypotenuse, and they're giving us this side, which it looks like is our adjacent. All right, paying attention to SOHCAHTOA, try to think for yourselves for a second, which of these am I going to use? Sine, cosine, or tangent? If you answered cosine, you are correct. We have an adjacent and we have a hypotenuse. So we know that cosine of theta equals adjacent over hypotenuse. Equals adjacent over hypotenuse. In this case, I can fill in those values. Theta is going to be 65 degrees. And the adjacent is going to be, our missing variable. So instead of calling it question mark this time, I'm just going to call it x. And the hypotenuse is going to be equal to 7. So if I want to solve for x, what I have to do is I have to multiply both sides by 7. These 7s cancel out, and I'm left with a 7 over here. So I need to do 7 times cosine of 65 for my final answer. And this is going to be x equals 7 times cosine of 65. So we're going to say, in this case, we're going to have 7 times cosine of 65. And I need to do 7 multiplied by that value. And I end up with 2.958, which we want to the nearest 100. And in this case, the nearest 100th would be this 8 rounds my 5 up, so we're going to say 2.96 would be my final answer to the nearest 100th. Okay, as I just did that problem, I realized I didn't actually say the final answer for the last problem. I apologize. We'll go back and look at that at the end of the video if you want the final answer for that one. Okay, so let's delete this and delete this, and we will try the next problem. Okay, so if I look at this problem here, I am looking at my angle is here. This is an opposite. And this side over here is actually an adjacent because my hypotenuse, my hypotenuse would be this side over here. So if I'm dealing with opposite and adjacent, try to think in your head which one would be using. And if you answered tangent, that's correct. We have opposite and adjacent, so it's TOA, like that OA. So we have tangent is equal to opposite over adjacent. And so if I fill this out, I have the tangent of 25 degrees equals my opposite value, which is what I'm looking for. So we'll call that my x over 5, which is my adjacent. So if I want to solve for x in this case, I need to multiply both sides by 5. And I get 5 times the tangent of 25 is my missing side x. So I need to actually calculate that with my calculator, making sure I am in degrees. 5 times tangent of 25 gives me 2.33154. Rounded to the nearest 100th, this should be 2.3. And then if I look, this 1 is not going to round the 100th place up. So we're going to say 2.33 is our final answer for this one. Okay, and we'll get rid of that. And that's all of them. I wanted to go back to the second problem really quickly just to go over the answer because I didn't list that. So if you've stuck in this long and want that final answer, now is where we'll talk about that. So looking at this really quickly, just re-remembering the problem, we have, it looks like opposite, we have hypotenuse. So we were dealing with a sine. So we have sine of theta equals opposite over hypotenuse. And we have sine of 65 equals our opposite side, which is 5 over our hypotenuse. If you guys remember, we can think of this as a transaction like this. If something comes up on this side, it must go down on the other side. And so we end up with our question mark value equals 5 over sine of 65. And if I do that, we can find sine of 65, and I need to do 5 divided by that value. And I end up with 5.516. And if I'm rounding to the nearest 100th, this 6 rounds it up, so I end up with 5.52 for our final answer for this second one. Sorry about not actually including that the first time, but that is all for this video. If you've made it this far, congratulations. Remember, questions can be directed at my email, or on Friday at 1, we will have a session where people can jump in and ask questions, what is going on with this trigonometry stuff. Okay, that's it. I will see you guys later.